In this video, I'd like to show you how to do the formulas for the Millikan lab. Okay, the first one is our velocity. Okay, so to figure out the velocity, all we're going to do is velocity is distance over time, right? Distance over time, right? And the distance is the number of divisions times the zoom level. For mine, I was always zoomed at 77.5 times 10 to the minus 6th meters, right? And then the time was 10 seconds, okay? So 5.86 divisions times 77.5 micrometers per division divided by the 10 seconds it took to fall that, okay? So let me just show you how to type that in. That's easy, right? So there's that cell. To make a formula, you type equals, right? And then it's going to be the number of divisions, right? And so I'm hitting, you can actually click with the cursor, right? It's that thing, right? Times, and here's how you type 77.5 times 10 to the minus 6. 77.5, and then you just go E minus 6. Okay, and it doesn't have to be a capital E. A capital E will work. It's not case sensitive. And then I'm going to divide by the time. And since I actually typed the time in here, and it, there it is, right? If you don't want to have a column for time, you can just say divided by 10. That's fine. Some of the timers were doing a different thing, but anyway, there that is, right? There's our formula, and then you can just grab that corner and drag that thing down. Boom, there it is. Okay, so that'll give you the velocity of these things. All right, is that right? Why is that one smaller? A2 divided by, yeah, okay. And now to find the radius, what we're going to do for the radius, okay, is we are going to, for actually let's do the, actually the radius formula, right? For the radius, we had a formula that looked like this, right? We had rho times 4/3 pi r to the third g. That was the force of gravity, right? Is 6 pi times the viscosity, right, times r times v, right? And then of course we can cancel pi and we can cancel one of the r's, and you end up with the radius being the square root of 9/2, and then in the numerator it's this and the velocity and rho and g. Okay, so let me show you how to type that formula into your thing there. Okay, so I'm going to go equals the square root sqrt left parenthesis. Notice if it recognizes, right, the formula. If it doesn't recognize it, that's bad news, right? And now I'm just going to type the numerator. So it's 9 times, and then the viscosity of air in this simulation is 1.81. These are, by the way, on your Millikan Oil Drop Lab handout. 1.81 times 10 to the minus 5th. Okay, times the velocity. Well, the velocity is what we got in this column right there. Okay, and now we have to divide by this numerator here. See all that whole numerator? We have to put that in parentheses. So divided by left parenthesis, we're starting the denominator. So 2 times the density of the oil is 128, and that's also on your lab handout. Look at the Millikan oil drop. Look at the bottom there. Okay, times 9.8, I think is what they use for their thing. I'm closing that denominator, I'm closing the square root, and I'm hitting enter. And there it is. And the radii are typically on the order of micrometers, so if it looks like that, we're probably pretty good. And then you can take that and go moingy. There we go. If it looks like that, it's probably okay. Okay, the next formula we have to do is the formula for the voltage, right? And so for this one, we had the density times 4/3 pi r to the third, the volume times gravity, right? The force of gravity on the drop, right? Okay, and that equaled VQ over D, right? V over D is the electric field times Q, right? And this was super easy. We're solving that for Q, right? Okay, so Q is equal to rho 4 rho pi r to the third GD over 3V. Okay, so now let me show you how to type that in here. let's grab that, right? So for the charge, that equals 4 times the density, which is 128, times pi. Okay, here's how you do pi in Excel. Type pi left, right, and it's a formula that returns the value of pi. It doesn't do anything else. Okay, and then times the radius, right? Now I'm going to show you a trick. I'm just hitting the left arrow here, left, and it auto types that cell address, right? I have to raise it to the third power. Okay, I'm right here. I'm doing this. R to the third power times 9.8 times the plate separation, which is the plate separation is 3.1 millimeters. Okay, and that's not on the thing. It's in the lab. They tell you that, right? So I'm going to go times 3.1 e to the minus 3. All right. So there's 3.1 millimeters. That's the plate separation. Then divided by, and I'm starting the denominator, which is 3 times, and then the suspension voltage, which is just my cell to the left there. Uh-oh, it's underneath the here, we'll hide the ink. Hide it. How do we hide it? Oh, there it is. Whoop, hide the ink, right? All right, let's go back here. Okay, and then I go end that, and there it is, right? Now, with any luck, this will be something on the order of, of 10 to the minus 19th. Okay, and then you grab that and you fill it down. There we go. That's all looking good. This is all looking solidly like it could be electron charges, right? If you're getting something that's 10 to the minus 17th or 10 to the minus 21st, that would be impossible. Okay, that's the end of this video. In the next video, I'm going to show you how to make the graph. Okay.